out today. Today we have two briefers. First is Colonel Gary Armistead. He's the chief of our Space and Reconnaissance Requirements Division, and he's going to give you a briefing today on the Joint Force Air Component Commander's Situational Awareness System. But before Colonel Armistead comes up, I'd like to introduce General Link to come up and give you some introductory remarks. General Chuck Link is the Assistant Deputy Chief of Staff for Plans and Operations. Before you leave today, if you haven't got them, you will have a complete beta video of everything you will see today except for the first couple of minutes, and that will not be filmed today. You'll see why when that is shown. Then everything else is available to you in the press kit. So, General Link.
Thank you, Mark. Good afternoon. Thank you for your time. What you're going to see today is an example.
Could you stand behind him?
All right. Sorry. What you're going to see today is an example of a work in progress. This piece of technology probably has its origins in some of the lessons that we took away from the Gulf War. The Gulf War is the first time that we have manifested the capacity of a theater airman to leverage theater-wide situational awareness on behalf of a joint force commander. Out of that and the explosion in information technology, we've built what we think is a pretty useful system to inform the decisions that a joint force air component commander must make. Before I introduce Colonel Armistead, I would just point out to you that what we have over here is contained in that box by the pillar, this projector here, and 3 phone lines. So anywhere that you could get commercial power and access to phone lines, you could put this piece together. It is our purpose to be as informative as we can, so if we fail to answer some question in our presentation, please feel free to bring it up in the question and answer period. Okay, Gary, you're on.
Good afternoon, ladies and gentlemen. I'd like to start by taking the lights down and showing you a couple of minutes essentially off the recording, and this will not be on your videotapes, and I'll explain in more detail as we look at it. This is a JFAC Situational Awareness System display, and we're going to take it through a few paces for you here, and there'll be a more detailed discussion following this brief presentation. What you were looking at there was the live situational awareness picture from the theater. That information is brought in, as General Link was referring to, over a few telephone lines and processed and displayed by the JFAC Situational Awareness System here, just as it's being done by the JFAC Situational Awareness System at the Combined Air Operations Center in Vicenza, Italy. That capability to show that type of display, we hope, provides the information awareness that the commander needs in order to make decisions in these situations where the rules of engagement require near real-time level of information with accuracy similar to what we're showing here. Again, that was live information, and that's what we did on the recording. Now, from here on forward, we're going to provide an unclassified discussion where we take apart the system and put it back together for you. It is that's on the videotape that we have. We have it in two versions, a beta version as well as a VHS version. And that is a full narrated show, so anything that we say here you should be able to take with you when we're finished. The following point I need to make, we are using Southwest Asia as the scenario for this discussion, and the information in this is scenario information. It is not real information. It is data that we put together in order to allow you to understand the capabilities of the system and how it works. In addition to that, you will see information that was collected in exercises that we have put into this scenario for Southwest Asia. We did that so that you could see it in context the way it would be in an actual conflict as opposed to just an exercise. One final point, in the unclassified demonstration, the time, of course, has been compressed so that you'll be seeing things happen faster than they actually would, and we do that, of course, because we have limited time here. One final caveat, if I might. I'm kind of new at this, so I may slip into using some acronyms. If I do and you're not familiar with them, please bring that to my attention and I'll try to correct it immediately. Otherwise, I'll do my best to try to make this as clear and concise as I possibly can. We'd like to start with this picture here, and again, what we're going to do is take you through the JFAC Situational Awareness Systems PACES using a variety of information, and I'll bridge the gaps as we come to them. The JFAC, Joint Force Air Component Commander, who may reside here in the CONUS in the continental United States at an air base with forces to be ready to go in response to a crisis or a trouble spot that emerges anywhere in the world, he needs a global view. He needs global information because you just never know where that trouble spot's going to come up. And so to begin with, with that uncertainty about where one might find a trouble spot, this global view is very important. He needs eyes and ears that are operating globally and providing information to him on a routine basis. And that normal source in this peacetime garrison environment would be the overhead eyes and ears that we have, which are mainly the National Reconnaissance satellite systems. In this particular case, since the National Reconnaissance systems are very classified, we're going to use some unclassified systems to represent them. And in this particular case, we'll be using the civil Landsat NASA system that we have, which provides some imagery, as well as the French Spot imagery satellite, which I'm sure most of you have heard about. One of the things that JSAS allows you to do is visualize the orbits of these systems and how they might collect, as well as their fields of regard and how the imaging systems work. In this particular case, you're seeing that the world would be spinning. These are the orbital planes that these systems are flying in. And the fields of regard are shown here as large for the Spot, smaller for the Landsat, and we'll show you a little bit more about that momentarily. As these systems fly, they fly across borders and have the opportunity to sample many potential trouble spots around the world, and by doing that repeatedly over days and months, information can be put together on a particular country's capabilities and their intent, and that information can be provided to the Joint Force Air Component Commander so that when a trouble spot flares up, he has something to base his force deployment and employment recommendations on. So these systems are extremely valuable as reconnaissance assets leading up to a particular deployment. Let me take you now and fly you on the Spot satellite as it approaches Southwest Asia. This is its field of regard here shown in green. That means it can take an image within that field of regard. The image itself is not that large. The area you're seeing up here in red is the target image site. And as the spacecraft approaches that target image site, if it were tasked to collect that image, it would lay down a footprint over the area and collect the image as it passes over. We're going to take and normalize this view now and let you see it not from on the spacecraft, but from a Earth observer point of view. In this case, the spacecraft's going to be coming down over the polar area. You see the field of regard here. That's the area to be imaged. Now, as this image is collected, it's collected by the spacecraft and put down to a ground station. This is quite typical of overhead collection systems. The image is processed and analyzed at the ground system. And the information that's revealed out of the image is then provided over various communications links to the Joint Force Air Component Commander. The image also can be provided over communication links, and when it is, it's then integrated directly into the JFAC situational awareness system. Now, in this particular case, the spot imagery that's collected is provided and is shown here, and we will take a look at that imagery. As you can see, the Joint Force Air Component Commander Situational Awareness System brings that imagery in context to the maps and other information that might be displayed at the same time. So as you might have seen on the earlier view, the contacts of aircraft and other activity that were moving into a theater, the commander would be able to see those contacts relative to the imagery collected. So if there's a particular point of interest in that imagery, then he can put that in context with the way his forces are operating from their current deployed areas. Let's zoom in on this imagery and take a closer look at it. This is typical of the spot imagery resolution that you see. The national system's resolution, of course, is much better than that. For purposes of this discussion, we provided an image to provide a simulated national view. That's in this smaller blue area here. And let's zoom in on that. And we'll take another tighter zoom. In this particular case, what's spotted is activity on the road here, and that particular activity has been analyzed and assessed as an armor unit that's deployed and operating along that road. As you can tell, the location that we have for discussion in this scenario is adjacent to the Saudi border, and therefore this is reason to be alerted and to have some degree of concern. The revealed information that comes forward from the analysis of this image can also be provided here, as I mentioned, through communications links and displayed directly on the system. And that, in this particular case, it would show an armored brigade deployed forward. Now, one of the first questions that the commander would have would be the relationship of this armored brigade's position and its activity relative to known garrisons and where the armored units are supposed to be. JSAS allows that type of database, ground order of battle database, to be brought up and viewed. These are the garrisons that we've put in for this discussion. Again, this is scenario information. And the armored brigade, you can see, is nowhere near a known garrison. So that raises a level of concern, indicating someone's out of garrison and operating, and that operational location is near the border with the Saudis. That would require additional information to be collected in order to resolve what might be going on here. In this particular case, we need broad area coverage. We need imagery across a broad area. And the best collector to do that today is the U-2 reconnaissance platform. So this would be one reason why that aircraft might be tasked to fly a mission. We're going to fly that mission for you now, as it might be flown against this scenario. Over here, the JSAS enables the commander to see the field of regard that U-2 might have. This field of regard is exaggerated for purposes of this discussion, so we don't reveal exact details of performance. It also allows the commander to see the actual track of the aircraft. Now, we're operating in compressed time here, so you may see the aircraft move a lot faster than it actually would. As the aircraft sweeps through the area, it's taking its imagery, and again, it's linking that imagery back to a ground station. The ground station's analyzing the imagery, putting out revealed information over a comm link, and then also providing the imagery itself within a near real-time response rate from the collection. And as that revealed information comes in, additional units are found operating in the same area. So the overhead system revealed a single unit forward. In the case of the U-2's broad area coverage, we're beginning now to get a better picture of what's going on in this area. As you can see, there's several deployed operational units in that area, which raises many questions about what might be going on. This is a sample of the type of imagery that the U-2 would be collecting. Now, at that level of activity, that close to the border, additional surveillance is now required. And in this particular case, we'll show you another platform called the Rivet Joint. That is one of our aircraft that provides electronic listening. And the Rivet Joint, in this case, will set up a surveillance orbit here, and this is its coverage that it'll provide. And again, the JSAS allows both to be seen. We'll show this in compressed time, and the coverage that's provided, again, is exaggerated for purposes of this discussion. Now, the rivet joint is listening to the electronic activity in the theater. In this particular case, we're showing a variety of responses. We're showing early warning radars up. We're showing air traffic control GCI type radars that are operating. And we're showing surface-to-air missile contacts, radars supporting surface-to-air missile batteries that are up. So clearly the other side in this particular scenario is also looking and listening for our response to what they're doing. And they're postured to be in their best position for both defensive as well as any potential offense action that they provide. Now, another surveillance asset that we can bring to bear in the theater provides some view of activity. That's the eyes of the radar systems. We have two that we'll show you here that JSAS can integrate information from. One of those is the Aegis radar system, sea-based, and the other one is the AWACS radar system, air-based. These are their coverages as JSAS would show them as the aircraft flies their track, and of course this is what the systems look like. AWACS track is set up here for surveillance, and the Aegis is out here in the Gulf. As it collects its information, the radar contacts are brought through the processing on board these systems and output over communications links, which are then integrated into this picture. In this particular case, you see 3 fighter contacts flying in northern Iraq. That indicates both a integrated air and ground activity that in this scenario, the Iraqis have put forward. One of the true values of this system is it provides the commander the ability to see all of this information integrated. In previous days, the radar information was on one screen, the electronic order of battle perhaps was on another screen, the imagery was on several other screens. Here, all the information comes together in a correlated and integrated view for the commander in as real time as the systems can provide them. Now, another set of radar eyes can look groundward instead of just to the air, and that's the JSTARS system. As you know, the JSTARS has been used recently in the Bosnia operation as well as previously, of course, in Southwest Asia. Here, JSTARS coverage is again exaggerated and shown, and one of the things that JSTARS is obviously looking for is deployed units. In this case, we're showing a convoy contact on the road, again headed toward the border, and that convoy information is shown by icon over here on the map. The system now allows some capability to zoom tighter in order to put this convoy activity in perspective. And as we move in, the map resolutions change, and if we had imagery in the area, it would of course be overlaid on the imagery. Here we're showing the convoy activity. It's labeled convoy because at this point we don't know exactly what type of vehicles these are. As the JSTARS finishes its mission and as maybe other eyes are brought to bear against the problem, this convoy could be characterized as to whether it's armor or motorized infantry or resupply. Now, if we take a look at the back at the full theater as we built it up here, one of the things of particular concern to any air component commander is the surface-to-air missile deployments forward in the theater here near the border. That suggests several things. One is that obviously they're interested in air defense, but also that they're trying to protect particular targets potentially that may be located of value inside these surface-to-air missile rings. So valuable relocatable targets that may be forward would include things like command and control. It might include things like Scud missile launchers, or any other type of valuable relocatable target that we might initially hit to disrupt the enemy activity. The unmanned air vehicle in this case provides us an opportunity to try to determine enemy capabilities and intent without having to risk a pilot to do so prior to the onset of hostilities. So the surface-to-air missile is active. UAV can fly into that area and collect information and provide that update to the Joint Force Air Component Commander to complete his view of the theater situation. He can also go over to the convoy and provide some additional information on what that convoy may be. As this UAV comes back through the ring, we'll show you the type of full motion video that the UAV can provide. And again, JSAS provides an integrated view of that information by opening up a window here. In this case, we can see the UAV has surveillance of a TEL, a remote launcher for the Scud. And of course, we're playing this in compressed time. Give you a larger view of it. and play it out for you. Of course, this provides us the knowledge up front that there is forward deployed strike weapons inside that surface-to-air missile ring, and one of the first things, should the commander be authorized to strike authority, would be to obviously suppress the SAM and destroy the Scud. But since the onset of hostilities is not here and there is no authorization to attack, one of the things, of course, the commander needs to know is, do I have additional surveillance that I can bring to bear in the event that the Scud is launched in the interim between the time I'm authorized to strike and the time I've spotted it? Those eyes are space-based infrared eyes, and that's the Defense Support Program satellite system. JSAS allows the commander to see where those satellites are and how they're covering the area. In this particular case, we're showing 2 DSP satellites. Again, this is scenario information. 2 DSP satellites covering the theater, and allows the commander to have that direct view of what that coverage looks like, where those satellites are positioned relative to the theater. In conclusion, then, the JFAC situational awareness system provides the commander the ability to have an integrated view of where the eyes and ears are operating that provide him the valuable information he needs. At the same time, it allows him to see that information in an integrated view that those eyes and ears are collecting. And it's that integrated view combined with that mastery of the reconnaissance and surveillance assets that gives the Joint Force Air Component Commander the unique capability to employ air power anywhere in the world he may be called upon. As I mentioned, this discussion you've just seen is captured on beta and VHS videotape for your use. The script that goes on the tape is included in your press release package, along with a copy of this chart. And if there are any questions, now would be the time that I could take to entertain them.
That picture that the UAV took, the video, what was that really of?
That was from the Roving Sands exercise from last year in the southwest United States, which is representative of what a Scud deployment would look like, and gave us a real feel for what the UAV's imagery of that Scud would look like.
How do you get the connectivity? What are your comm pipes? And
Okay.
what you said it's as near real time as possible. What is it really?
Okay. The timing varies for different pieces of information. As I mentioned earlier, the imagery requires processing and analysis at ground stations and then is forwarded. Some of that imagery can be available within 20 to 30 minutes. Other of the imagery takes longer. And of course, in some cases, the imagery is near real time, meaning just a few minutes or seconds after collection. So it varies based on who's collecting the imagery and how much analysis and processing is required. Your other question regarding the total communications packaging here, there's several tactical type broadcasts that are operating in any theater. JSAS provides a communications suite capable of collecting all of that information over antennas and processing boxes to bring in all the communications information in for direct display. So if your satellite communication or line of sight from a platform, you can pull that information from the communications rack and display it. Some of those communications links are things like tattle A, B, or J, TIBs, trap, etc. There are quite a few of them.
Do you get the information directly from the sensor or from the platform? Or do
In
you-
some cases, the communications link is directly from the platform. In other cases, the communications link is from the platform to a ground station, processed by computers and then released within just a few minutes of collection.
What if you downlink from the U2s to someplace like Albania where the telephone lines stink? I mean, what, seriously?
We are not using telephone lines in deployed mode. We're normally using UHF and KU-band antennas with JSAS through our communications rack. What we're trying to show with the telephone lines is our ability to set this up in short time almost anywhere. Obviously, we can set up antennas here in the Pentagon and have. In deployed situations, that's the first thing we do is drop the antennas. The antennas, the UHF antenna is about this big, and the KU-band antenna is about that big.
So local landlines wouldn't be a major problem?
No.
Where is it deployed now?
It is currently deployed at the Combined Air Operations Center in Vicenza, Italy, supporting the operation for Bosnia.
And it's scheduled to go other places, or?
The Air Force Special Operations Command has a JSAS unit which was previously deployed to Italy. It has now been relocated to a new operating location for a particular AFSOC mission.
Is there a need for more than 3 units?
We have a request from our Air Combat Command for several of these units to be deployed to all the key numbered Air Force commanders who might find themselves as a Joint Force Air Component Commander. And as I indicated earlier in the discussion, the need to have this while you're at peace in your garrison waiting for where you might be deployed is valuable, perhaps not as valuable as having it once you are deployed, but it is extremely valuable so that you know what is happening as you lead up to a possible crisis.
Two questions. In Vincenzo, was this used last fall to help plan NATO's airstrikes?
Yes.
So it's been there since last summer?
Let me back up and say you use the term plan. This system is for situational awareness. It can help adjust a plan in progress, and that's primarily what it's designed to do. As you see units operate, you see threats come up, you see targets of opportunity come up, you can shorten your reaction time based on the capability that you see here. It is not intended to be a mission planning rehearsal tool.
Was it used to help
Yes.
orchestrate?
Yes, it was deployed for deliberate force and operated in the Combined Air Operations Center as the primary situational awareness tool during deliberate force.
Follow-up NRO participation to help get satellite. There's national assets.
Right.
What cooperation are you getting from NRO?
We've had excellent support from the NRO from the beginning of the effort here, and they continue to support us, and they're very, as you know, with the security declassification activities that have been going on in the NRO since the end of the Cold War. That has enabled us to bring this closer to the commanders in the field in near real time than ever before. So I would say that their cooperation has been very key to the success of this system.
Are there any platforms you haven't been able to integrate airborne reconnaissance low, EP3?
EP3